All right, what's my goal right now? I want to imagine points up here, maybe along a hyperbola from some common center. And I want to take these points up here, which are x comma y. X equals r, where r is this, r cosh phi comma r sinh phi. And so basically I'll take that x comma y and I'll calculate r and phi from it. And then I'm going to want to take those and drop them down by an angle. So now we have r comma phi. We have this r. Well, you know what? I'm going to have to figure out something involving that. And I think, okay, but the question is, where do I want to swing that down to? And the basic idea is I want to swing it down until this line has the length, the horizontal length, equal to the path integral, which is going to be the path integral of the square root of dx squared minus c squared dt squared, where dx is r cosh phi, so dx is r sinh phi, and dy, well, dy will be r cosh phi. And we'll just ignore the c, and we'll just kind of put square root of r sinh squared phi minus r squared cosh squared phi, which would be what, the square root of -1? Well, we're going to be taking the integral from 0 to our phi final. I think I've got this backwards. Here it should be x equals r sinh phi and y equals r cosh phi. So that would make sense. This is going to be plus and minus down here because these are reversed. So that means that our ds is going to be the integral of r d phi, as phi goes from 0 to phi final. R is not a function of phi, so it'll just be r phi. We'll be taking this point here to a point that is at r sinh phi comma r cosh phi and moving it over here to a point which is x equals r phi comma and then x equals r phi and then the y variable is r because it's the same height as this one. Okay. Now the question is, can I use image transformation for this? And if so, how? Image transformation. Here's our identity image transformation, which just takes pound1 and pound2 and takes it to itself. So the x variable is 1, the y variable is 2, and there's also image forward transformation, which in this case it looks exactly the same, but it will do something different if I change one of these away from the identity. Like say I put the square root of 2 in the second area, then you can see it kind of shrinks the backwards transformation down to the bottom, and it just shrinks the forward transformation up to the top. So for image transformation, you can see this bottom part is covering most of the photo, and that goes at the bottom here. And then this part covers the top half of the photo, and it's kind of spread out over a larger region. With the image transformation, you can think of this left-hand side being the input space and the right-hand side being the output space. So in the input space, the bottom of her shirt takes up a good 1/3 of the picture. In the output space, that 1/3 of the picture is pushed down into the bottom 10% of the diagram. What we're going to do is we're going to take our sine phi, comma, our cosine phi, and turn it into r phi, comma, r, and see if we can come up with a method where all we've got is pound 1 and pound 2, in other words, x comma y. And so and cosh, and cosh phi is going to be, let me think for a second, r x equals r sinh phi. So, and y equals r cosh phi, and y squared minus x squared is r squared, right? Cosh phi is y over r, which is y over square root of y squared minus x squared. And tanh phi is going to be x over y. So phi would be arctanh of x comma of x over y. So if we're going to map x comma y to r phi comma r, we need to send that to r, what is it? R is square root of y squared minus x squared times phi is arctanh of x over y, and then comma r is square root of y squared minus x squared. All right, let's try this. I'm creating a function swingDown, x comma y, which calculates in it r and phi, which is square root of y squared minus x, and hyperbolic arctangent of x over y, and then just returning r phi comma r. So what I'm going to do here is try to apply that function and see if just the notation is right, and then we'll see if we can get it centered correctly. So I'm going to do swing down, and then instead of x comma y, I'm going to go pound 1 comma pound 2. Now it's taking a little bit to run because it's using that function in every case, and that's what it gave me. How lovely. And then I repeated it, this time also doing an image forward transformation. This time it didn't come out with stripes, it came out completely black. That seems strange. What happened? In order to get more things on the screen, I tried plot range all, and something occurred to me that we are outside of the scope of this function. So Let me put a conditional in here saying if r is greater than 0, we'll plot it at r phi comma r, and if it is not greater than 0, we'll just plot it at 0 comma 0. That may or may not work. But then it says invalid comparison with 2.99071. So it's coming out to be a complex number. So rather than asking if it is greater than 0, how can I ask it if it's in the reals? All right, I tried element r comma reals, and we're not getting what I want, but at least we're getting something that looks kind of like the shape I was expecting, or something sort of related to the shape I was expecting. I think I may give up using image transformation to do this thing and just go back to creating lists of points to do the transformation on.